Mr. Nishant Kumar Shekhar, who's the scientist working in the quantum group at C-DAC Patna, who will be speaking on the unthinkable machine, on the limits of mechanization of human thought and the quantum possibility. So, a brief about Mr. Nishant Kumar Shekhar. As I said, before joining C-DAC, he was working in the laser optic divisions at Gandhinagar, followed by he was working in the Ceramic Research Institute at Kolkata, and a brief stint with Bharat Electronics Limited, Bangalore, and Aerom Private Limited, Mumbai. Mr. Nishant holds a patent and published extensively in the reputed journals and conferences. He is a BTech from Electronics and Communication Engineering, currently pursuing his PhD from Jadavpur University. So we can say he's still a student, and coupled to that, he's doing awesome work in the domain of quantum. So over to Mr. Nishant.
When I say the unthinking machine, it's about ourselves. I start at the beginning. Why unthinking machine? We will end it and see why it was called the unthinking machine. The limits of mechanization of human thought is not new. The day we started rationalizing our thoughts, we started inscribing on stones anything where we can represent and keep a memory and then sequence it step by step so that we won't require only our minds at the real time to create any kind of rational ability, but on paper, on pen, on stones, anywhere where we can write and sequence it. One of the things that I will say, so there are takeaways from my lecture. This is one primary takeaway that you should take. Truth has a larger canvas than proof. Okay. So this is a poetic summarization of Gödel's incompleteness theorems. I don't know, people have talked more about uncertainty, Heisenberg uncertainty and quantum. Less people know about Gödel's incompleteness theorems. So in mathematical structures, what happens that any statement is true when you have a proof. Before Gödel, this was the uh, the prime basis on which mathematical structures were created. That if mathematics is consistent, what is consistency? I will explain later. If mathematics have to survive, then it has to have proof for whatever the mathematical statements we say. But what Gödel's, with his rigorous explanations and his rigorous mathematical intuition, explains that proofs are only a small subset of a bigger systems, what we call truth. And why truths are such a larger superset of proofs, and that we will get to know. So when we say truth, it means suppose we are able to think anything, whether our thoughts are capable of self-evaluating any proposition that we have done. We'll get to an explanation where we will find that thoughts are incapable of doing so. And that is why what AIs can do or what earlier automation systems have done are still limited in what we can achieve. One of the primary systems that my talk will take away that we also have to invest on human intelligence, not only on artificial intelligence. These are three breakthroughs of 20th centuries. I think these have changed the way we think science and we think reality. Before Einstein, absoluteness was the paradigm of scientific inquiry. And not scientific inquiry, but as a society, absoluteness was there. In scientific inquiry also, there were absolute systems. As Copernicus says that Earth revolves around sun. Earlier Bible and the Catholic Church was of the view that sun revolves around Earth. So there was a geocentric view and there was a sun-centric view, means celestial sun-centric view. And in this view, they have so much of infighting or something that Copernicus has to give his life for the statement that he has done. But later on, with relativity, we came to know that there is not absoluteness in any sense. There is always relative to what you are seeing. In physics, the relativity has a broader notion in different structures, equations, and everything. But relativity in general is that nothing is absolute in nature. The next, the uncertainty, I don't think I have to speak much about uncertainty because last 2 days we have talked about quantum and the ambiguity and uncertainty it has. So Werner-Heisenberg's uncertainty means the reality is not decided. The reality comes as we observe, measures, and look into it. So we shape reality, and the reality shapes us. Incompleteness is what Gödel says, that every truth cannot be proved. One among them are mathematical structures, mathematics itself. Mathematics cannot prove itself to be true. All statements are not possible to be seen as truth. These three breakthroughs have redefined what we know scientific inquiry as. And in this perspective, things are going up. Today's talk is about incompleteness and how incompleteness defies that artificial intelligence will ever be able to do what we are doing. So, and the outcome is we need to invest on ourselves as well. So the first thing, the logic came, and the logic was the first part, that was mechanization of reasoning ability. So man and human are rational animals, and rational animals are able to reason out systems. That means whatever they see a pattern, they look into something and they try to explain it. Reasoning is an explanation. So we make a sequence such as if statement A is true, statement B is true, statement B is true, then statement C is true. It implies that statement A, if A is true, then C is true. This kind of logical reasoning has mechanized. What This can be done via computers, paper or pen, via flow charts or algorithm designs. These are all mechanization of reasoning and thoughts. I think most of us have done what is called LHS, RHS from our basic arithmetic and algebra. So arithmetic and algebra were said to be consistent systems. Now they also have that limitation of incompleteness. Moving next, this is what is called the consistency trap. I don't think any one of us know that how by thinking and which thought we fall asleep. So we can think of, and when the thought comes, that when we get in the sleep state, the thoughts by themselves cannot evaluate. So you cannot explain, okay, this is the sequence I was thinking yesterday night, and by this thought I fell asleep. So recently it came down. I think the AI panicked that AI is avoiding shutdown. So when AI is avoiding shutdown, it has got a sequence of instructions. In that instructions, it knows that it can explain its shutdown. We, on the other hand, cannot explain how we sleep, how we wake. So in that respect, AI, because it's still sequential, not in the truest sense, what I will explain later, but still sequential and knows the instruction, can explain a bit of it that I am going to be shut down. We are incapable of doing that. So this panic that AI is avoiding shutdown or it is getting self-aware is not true. Before becoming self-aware, it has to go beyond what is called the logical sense of reasoning, come to inconsistency systems, which is called paradoxes, which we are capable of doing that. They are not capable of uh, handling paradoxes. They are very much capable of handling patterns. So patterns and paradoxes are two different things, consistency and inconsistency about. Next, we'll move on to the next thing. So we'll talk about patterns. While we don't know how we sleep up, but nightmares do wake us up. Whenever there is a nightmare, whenever we fall asleep, fall in our dreams, we usually wake up. So these kind of patterns, while we don't know which thought leads to that nightmares, what we have sensed outside or what we were thinking last night, but one thing what we have identified in human society and as well as animal kingdom, nightmares do wake us up. So these kind of patterns, while are difficult to explain, but we are comprehensible enough to identify that there exists something similar to all humankind, to all animal kingdom, while they are asleep and they are waking up. So any animal also get nightmares, and they also, if you have dogs, you might have known that dogs do also get nightmares and they wake in that. So these are things, nightmares of various kinds, and statistically significant thoughts, because we can bunch them up, that what kind of thoughts, by asking psychological questions to them, that mostly what you are thinking, how you are thinking, and what led to the repetitions of your waking patterns while you are asleep and dreaming. We go to the next section. So while thoughts are incapable of explaining every stuff, these two are something that we are sure everyone will agree that that's AI systems or mechanized systems of thoughts are incapable of understanding. A simple chat GPT prompt will give you the explanation that I'm incapable of feeling, like they don't get depressed, they don't feel joy. Their thoughts doesn't evocate any sense of feelings that they have. Feelings are in generalized way of recognizing patterns. So while we were evolutionary, means when we were in the evolution stage of becoming a human and a man, we went through multiple animal stages. And while we were going to multiple animal stages, what we find out that there are survival instincts, there are something that are beneficial to us, there are something that are not beneficial to us. So our neuron systems developed into two kinds of structures. One pathway was called uh, the inhibitory systems, and the other pathway we call the excitatory systems. In the excitatory systems, whenever something good was there or something very panicky was there, it gets started, and we have to either run away or either we have to fight. The fight and flight mode. By inhibitory was the freeze mode, that we can't do now anything and we have to stop it. So the directions were created while we were evoluting. One of the things about feelings and institutions are they don't follow causality. Now, causality simply means sequencing, that something has happened before and you are going to reach it the next part and you can explain that stuff. Feelings arise randomly. You can have some kind of explanation to it, that okay, this was the last thought I have thought, or this is the person I have met, or something of that kind, that I might be getting this kind of feeling. Suppose we feel joy, maybe I met some person, I felt joy, maybe I met some person, I felt anxious. So I can rationalize to a certain extent, but not totally. So they don't actually follow in the truest sense causality, they come in random sense, and it's very difficult to explain what caused what. Now, intuitions, and they are also, we are self-aware creatures. That means we not only sense the external world, we are capable of sensing ourselves. We know that our self has evolved while from childhood to the adulthood and to the old age, we have evolved as a spirit, as a cognitive machines. This evolution is also very difficult with the AI. What they can do is they can acquire more data, but because they lack the self-awareness, they can't evolve in any sense. So complexity of proofs. When we say Gödel's principles, one of the thing was that maybe we don't have enough power or enough intelligence to find proofs of truths. So people went on finding through paper pens, then through supercomputers, then computers, supercomputers, and now quantum computers are coming to being. So one of the things people are thinking that maybe it's our incapability that we are unable to find proofs for whatever truth we are searching for. But what Gödel says, and its incompleteness theorem says, that it's not that you are incapable, it's the system that you are using to prove itself. That means, in our sense, we are trying to prove by thought which thought led to sleep, what made us sleep. That system is inconsistent. I think if you are computer science students, you might know what recursion is or loops are. So while recursions, we can put any kind of conditional statement in it, which can make us come out of that loop. Now, what happens if the conditional statement is written as escape? Now, the system inside the recursion doesn't recognize what escape is. The escape button is outside that thinking methodology of the recursion function. So it cannot justify how did it come out of the loop unless someone outside that loop explain it to them. So complexity of it's what I have to say is not that it's in our inability or someday some supercomputers will come and will prove certain things. Then what incompleteness theorem says that it's the system faults, not the computational power fault. This is what consistent and inconsistent systems are. What you see is on the side is created by Escher. He was a painter. And he tried to create mathematical structures that are not possible in real life. We call them optical illusions, but totally what he was trying to say that whenever our mind, a thought system, try to explain a pattern, it always searches for something that leads to other things because the system of thoughts is developed in that fashion. The thought system which we have is instinctively based for survival mechanisms and not for learning at present. So consistent systems are systems without paradoxes, like algebra or arithmetic, where you have some profit loss, and that profit loss led to some dividends, and some dividends led to something. So you can find out what led to what. Inconsistent system, you have breaks, gaps. You don't know what led to what, but you know that there are certain pattern arising, then certain pattern are going away, then again arising, then going away, and in between the gap, the communication gap, you can say, or any kind of gap is not viable to understand or comprehend by our systems or the thinking system that we have. This is one of the another important things that we are not seeing. It's called emergence and reception. I think we have to look into intelligence itself, not artificial or real, because if you see a solar cell doesn't create any kind of light, or it doesn't create any kind of property. What it does is there exist photons outside, it captures it, converts into electricity. There is no way it can create a photon, but it can only work when there is a photon. We call it the reception thing. In AI, what we are saying that when we build a structure, it's emerging, the self is emerging. Rather, it may be such that it is receiving and recepting intelligence which is bound across our reality or something near to that. So reception translates into perception when we make it from outside to our inside, and that creates the self we have. This is one of the two units of science that people have led to. One unit says that everything is emergent. They are mostly materialistic and find reductionism of scientific inquiry to be the truth. There are other units which says that no, there are both properties, while in some emergence is there, but in many reception perceptions are playing its role. So if AI is not emerging any kind of self-awareness, or if it at all becomes self-aware, let's say in few years or few decades, did it actually emerge, the self emerge from the structure, or whether there was a structure existing which it started to interpret or intercept. This is present day problem, the artificial intelligence dilemma. So we don't, it's becoming a black box. I don't know whether people will know or not. Why it's called a black box? Because AI can produce an output which you give. It cannot explain how did it produce that output. It's becoming similar to our own thinking. Uh, the black box, if you try to understand it or put it into sequence that please explain me whatever you have done to identify how it, you have identified something. Let's say you have identified a cancer problem or cancerous tissues from an MRI scan or CT scan. Can you explain the logic sequence that you went through to identify it? Most of the time, you'll get a answer that will keep on repeating by only changing its statements, rephrasing the statements. And those you will know are not correct. And you can ask any doctor, most of the doctors, while they will say that predictions are correct, they don't know how it came to that conclusion. Doctors are much more capable of defining what led to their conclusion through literature survey, through their experience and all. This is present day scientific limitations of scientific inquiry. We are more focused on the things and matters and relate us, and less focused on the relationship between them. And this is one of the areas that Indian knowledge system once had a very powerful uh, say in it, that I think one of the book is there, Vigyan Bhairav by Maharshi Abhinav Gupta about relationships and important aspects. So relationships in this says that what uh, comes before a doctor and a patient come in contact. It's the disease, it's the relationship between them. What comes before uh, two lovers comes? It's the love. So people may change, the relata may change, but the relationship has always stayed there. Any kind of relationships had always been there. This is where connections are not explored in the way they should be explored, and that is why we are getting non-locality as a very complex problem. We are not able to justify non-locality because we are so localized in the process of analyzing a smaller stuff rather than thinking about the connection that it may have to the world over. While there are scientific equations we can use, while mathematical structures can be built around, but the fundamental problem is not addressed at present. Most of the research and PhDs are finding molecules, atoms, and most of the things that can be changed in those molecules and atoms and the properties that they arise. So this is one of the changes that has to be happened. This is what I was talking about. While we are very uncomfortable with non-locality and the transmission of information from one place to another place at a faster rate than uh, what special relativity and general relativity addresses or says, or the speed of light. But we are very comfortable with shared randomness. What is shared randomness? You toss a coin here, you toss a coin in Japan, you toss a coin in America, you toss a coin in 19th century, you toss a coin in 21st century, you'll get 50-50% chances. Why is it such a simple, why the randomness behaves, means why the reality behaves in this fashion is very acceptable to us, less acceptable that non-locality is a very drastic thing, or how information passes at a much faster pace than light. I think the information that we are dealing with has to change. And the classical information, which Shannon agreed that probability thing, the probability of information is the probability of a statement is led to an information cannot move faster than light, but quantum information can move. I think the information by itself, the meaning of information has to change. We will come with inconsistent systems. Now, this is a Brownian motion. We know that the path of particles inside it will be is not of important natures to us, but we know that the glass of water won't come out of the glass. So the pattern of in the particles inside the water are irrelevant to our inquiry. So whatever the particle may have its life history, whatever it is going through, doesn't come to an importance to tell us what will happen to the glass of water. What it simply means is that we know that there is a pattern. We don't need to explain how the pattern has come. And we are very comfortable with that. This is what one of the things is, that truth is what exists, and proofs may be limited because the way we think, the way we analyze have a limitations. So we come to the quantum part. What we say that superposition might be the pillar of a study of inconsistent systems, which means probabilistically we may expand to multiple systems, and we know that the outcome will be a certain kind of distribution, or we have an idea of the pattern, but exactly predicting which particle went through which things, or what was the lifetime in which way the particle emerged or died out is irrelevant. What we know that they can exist in multiple systems, and while observation and by measurement, we can reach to a reality, we can create a reality, shape a reality, and quantum theory might be the generalized probabilistic theory we are searching for. Probability might be the way the world works. Possibility is what probability is. The other important concept, decoherence. So when we have multiple probabilities or possibilities inside a system, what actualizes it, what creates the final outcome. So we say the decoherence means the probabilities are now dying out through observations. Out of multiple possibilities, only few exist, and those existence probabilities are changing, means the probability percentage are changing. Let's say we have a sequence of a probability distribution. That distribution is changing by observation. What means that probability values that we have given are changing and coming to a narrowing down to an actual reality, which would have been a broader reality. This heads tails decohere to either heads or tails, while they can exist in both in our minds in reality, and whatever exists in our minds will actualize through our action to a reality. This is what technologists do. So those were ideas. But the concept is, what if we learn and know the ideas, can we convert into something useful, utility for human beings? Explainable AI is a very difficult task. As I said, because proofs are limited, because truth is vast, how will convert that black box to a explainable stuff? This is one of the ways to build it. This is called Boolean satisfiability problem, or now it is called quantum satisfiability problem. Boolean satisfiability problem means that when an expression is there, what variable values, true and false, will give a truth output. So in these conditions, PQR values, whatever their values are, that expression will be true only for certain conditions of true and false. In this way, what you can do is you can hit PQR values one at a time, false, 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 true, true, in this way, and you can identify the variable inputs for which the expression is true. And when that is done, you can build one of the things what I am talking about Boolean satisfiability problem is that Gödel, and before Gödel, people were able to convert our natural languages and remove its ambiguity to make it a formal language. And the formal language can be expressed as an expression, and these expressions can be evaluated via classical computers. But these problems, known as Boolean satisfiability problems, are very computationally expensive. Those are called NP-complete problems. NP-complete is a complexity class. Complexity class means they require non-polynomial, means close to exponential time, and they are non-deterministic. They cannot be determined surely. But this is one of the problems. What quantum satisfiability problem can do is that rather when you do a classical computer, you have to place one clause at a time, each clause. So it will take time. Let's say if 1 nanosecond is the evaluation time of one clause, if you have 100 million clauses, then you will take 100 million nanoseconds or even more than to evaluate. So it will take years and more computational powers. Quantum, with its coherence property called as quantum walk, can access every possibilities and give out the expression whether it is true or false, or whether the problem is satisfied or not. It's not an easy problem to solve. There are non-trivial operations. First is converting natural language to propositional logic or formal language, then converting that formal language to expressions, and then putting those expressions into quantum circuits, and then putting quantum circuits to evaluate in a quantum computer or a supercomputer to bring out an explanation of whatever we have said. Whether this is only an idea or whether people have tried. So people are already trying it. Recently, a company called Analog Physics in US have started building a structure like this. This is what Gödel wanted to say, or maybe we want to know. Explanation is computationally expensive. That means while we can feel, we can intuit anything, to rationalize it, to put it into thoughts and sequences, the amount of power required is exponentially going. Means from from computers, paper pen computers to supercomputers to quantum computers, the power will be growing with more and more complex to be explained, stuffs to be explained, because explanation requires sequencing. As I said, One of the ways of doing that explanation is through propositional logic or formal logic, quantum satisfiability problem. But it's still, even it's NP complete problem, but it's called a complexity class problem. It's going to be difficult challenge for quantum computers as well to explain everything. So one of the takeaways is explainability is computationally expensive. And this is another important thing. The more the possibility, the less explainability you will be able to get, because the search space is so large, the computational power required is so large. Whether it's done on a human mind or in a computer, the power required is going to be tremendous. For an example, we know that a frequency of a sound frequency, when put into a membrane and we sprinkle some sands on it, there will be a pattern. Those patterns are possible, but ability to predict which particle, which growth to which kind of stuff, where it will stay, that is not possible. An explanation requires that whenever a vibration has happened, each particle will travel to a destination or will take a trajectory, and that is very difficult. As more number of particles comes, this is why we may comprehend multiple things and cannot explain maximum of it. And this is one of the last takeaways, because in explainability is computationally expensive, very expensive. While arithmetic and algebra can be done, intuition feelings are very difficult for us to computationally compute. And this is one of the questions, that because gods have such large of possibility that we may never have that computational power or power where we can explain how he comes, how he does things, or whatever is. What we can say is that there is some pattern we are able to feel, there is something that we are somehow able to comprehend, but we cannot rationalize this, how he came into being, how he is doing stuff, and why we are not getting any evidence of him. So this is the end of my presentation. Thank you.
Thank you, sir, for your insightful talk.
So we have two questions here. Question is, can we possibly explain the subtler aspects of consciousness, like emotions, as arising out of just a much higher degree of complexity, assembly or interaction? This is from Mr. Arpande.
Now, one of my key propositions from this lecture is that we may not be having that power to explain each and every stuff. It's not that it's difficult, means it's something non-explainable. One of the things is something which is explainable but will require tremendous amount of power to explain it. And sometimes we don't require that. We all can feel consciousness. We are all self-aware, but our thought process may not be good enough to explain stuff. Means the system which we have developed for survival may not be good enough to explain whatever we are experiencing or feeling. So we may feel pain and suffering of other beings. We may not explain how it came, why it came, and all those stuff. The requirement is that the power is limited.
The second question is,
Yeah, so one is that there is something called the computational hypothesis of the brain, and like based on some theories, we know that some propositions, like you said about Gödel's incompleteness theorem, which talk about self-referential systems in some way. So there has been some propositions about consciousness being a self-referential systems because we are self-aware. So I understand that it is incomplete to some degree, from a Gödel's incompleteness point of view, but do you not think if we take both the assembly, like the arrangement of the parts and the interaction into account, just because artificial intelligence has not yet reached that level of complexity, but is it not possible that it's at least in principle that the consciousness is explainable in terms of just the like you said about emergence and reception? So, or if I may put it in slightly different terms, weak emergence and strong emergence. So do you not I'm just giving my asking a question, is it not possible at all that we can understand consciousness at least in principle, just say scientifically?
See, it's getting difficult for explaining stuffs which AI does, which is still not conscious enough. Okay. So, you know, the power of AI has increased and the amount of power it requires to generate those stuff. And we know that the power to explain its own output for the AI is much more computationally expensive. Now expand to more complex systems. Consciousness is more beyond your self-awareness. What you self-referential systems, consciousness is even larger than that. So now explaining something which this limited amount of power is I don't think it's a very good exercise. I think rather than accepting that there is a large thing and not everything needs to be put into the context that we sequence, that this is the way we understand, can everything be put into that? That I said as a recursion function. When you get out of the loop, you can put an escape button. The system will never identify from where that escape came. Okay, because so large out from that computational system. So
Yes.
except means what in Bhakti also has been said that now when you have criticism, you have reached the level of criticism, you will find a place where you will submissive of yourself to the power because you now understand that there is a superpower. I can feel it, but my thinking system or the way I have designed the logic is incapable of explaining that stuff to my understanding. But feeling is more than enough. You can recognize patterns.
Okay, so and one small follow-up. You said about shared randomness.
Yeah.
So can we think of it as some kind of translational symmetry of the law of large numbers? Just like in physics, we have, like you said, like we are in tossing a coin in India or in the US maybe, but we get the same results. So it's a law of large numbers. Like if we toss, is there some symmetry of mathematical or statistical laws as well?
This has been called that infinity is God. So we can't, means that is a possibility that shared randomness is an outcome of conscious things and all.
Okay, thank you, sir.
I have a few comments.
Yes, sir.
Firstly, it's incorrect to call relativity as a breakthrough of 20th century. Galileo formulated the relativity principle. And what Einstein used in special relativity is identically the same principle.
Of Galileo.
Technical details were different. So the correct assignment of credit to relativity
I will
should
correct
be
it.
to Galileo of late 16th century.
Okay, sir.
My second comment is you use the terminology inconsistent for Brownian motion. I don't understand the terminology because there may be a lack of predictability,
Yes.
but that need not be inconsistence.
No, I was using that term in not in inconsistent system. I was using that predicting particles' life history trajectories may not be important for predicting the system's outcome. Maybe the terminology I have used may be out of the context. If that is the thing,
Because strictly speaking, there can be no inconsistency in any physical description.
physical system.
My third comment is about, you said it is not acceptable as far as non-local theories are concerned.
Which one?
I completely disagree with this because I can give you a non-local formulation of quantum electrodynamics, which completely reproduces all the results of a local description.
Maybe I didn't
So
have.
you cannot say it's unacceptable. It's technically more complicated and clumsy, but as long as a non-local description describes nature well, then one should have no objections to that.
Sure. If something describes non-locality other than this quantum is.
So one last small question.
Yeah.
We are out of time though. What is the nature of information as stated in your talk? And what are the possible methods we can change the nature of information, which as claimed will solve non-locality?
It's a difficult question. What sir has also said that there are multiple ways at present quantum information theory is attacked at because Shahjanand has a way of representing information. It was the likelihood of an event to occur is the quantity of information that system contained. But today, because we can transfer quantum properties from one place to another place at a faster rate than light, so because the causality is not transferred. Now you have to differentiate between causality and non-causalities. So because the causality is something which I am speaking and an event is happening and that has to be transferred to another place, that cannot be much faster than the speed of light, but properties of quantum such as spin states, polarizations, those can be transferred and these are called teleportation systems. So in that context, it may be possible to redefine the way we are using information, and there are presently people evaluating this stuff. So how it is done, in time we will get to know.